All right, recorded is rolling. It is Thursday, January 18th. I have a spring oscillation lab lined up for you guys. You guys are already copying down that table before I hit record. And we're going to gather a bunch of data. I'm going to have you guys make these 4 graphs. Right. So some extra stuff. Textbook puzzles are due tomorrow. Right? Some of you guys probably already had those done, already turned this in, but not due tomorrow. And then before you guys leave today, I'll get you guys your next quiz, and let's have that due on Monday, so you guys have a few days to do that. All right. So what's the scenario here? All right. You guys have places to. Oh, you guys have these vertical hooks, so you got and some springs and some lab weights. Okay. So yesterday I threw this question to you guys. Said suppose there's just a spring hanging there, vertical with nothing on it, right? And then you do hang one of these lab weights. Okay? Now, if you just drop it, let it go, then it's going to stretch some maximum amount. And then it'll oscillate back and forth. Right? Now, eventually it'll come to a stop, to some equilibrium point. Okay? And one of the questions I asked you guys yesterday was, well, what is this maximal stretch versus this equilibrium stretch? And what we came up with was it'd be like twice as much, right? At least that's how the math says it should work out, right? So the maximum stretch you get from conservation of energy, the equilibrium stretch you get from dynamics and force equilibrium, right? So you get 2 different lengths. Right. So let's see empirically how close that lines up. Okay. Also, so you guys have some rulers, you guys have some stopwatches. I want to know something about oscillation too. So we're going to eventually make these 4 graphs. Here is what these graphs look like. So I'll put this up later in class today. Help you guys out. What is the maximum stretch versus the equilibrium stretch? Right? Guys, what do you think that graph is going to look like? Max stretch versus equilibrium stretch. What should that graph look like? Suppose you have different masses. Say you have small masses, big masses. You guys all got different masses, right? So that'd be sort of like variable, right? So as the equilibrium stretch goes up, you guys think max stretch is going to go up? What ideally should that graph look like? Right? Well, let's see by the end of class. Right? What about different weights versus equilibrium stretch? Right? So you hang on different weights, see different equilibrium stretch values. Right? What's that graph going to look like? Right? And then why did I put this on the y-axis and this on the x-axis? Maybe if this linearizes, and I think it'll linearize, right? Hopefully you guys are thinking that too. What would the slope of that straight line represent? What physical quantity? Okay. Right. Then, all right, for the oscillation section, notice I have time period on this next graph here, time period, right? Ooh, I bet there's like a time period of oscillation. You guys have stopwatches. And as you change out the masses, use different lab weights. Right? Maybe we get different time periods. Right? So do you guys think different lab weights, different corresponding time periods, one of the things you'd be expected to do is to linearize a graph, right? We did some graph linearization earlier this week. One of these posters shows one way to linearize a graph. That this is one way to linearize it. I guess ideally, I should have left those axes blank, and I should have just given you guys the, just told you guys to linearize a graph. And there are multiple ways to do it. Now, the way I set it up, there's a specific reason I did that, right? Because, yeah, this is going to linearize. And then the slope of that line will represent a certain physical quantity. I want to see if you guys get that. Right? And then what if you just do plain displacement versus time? Right? Displacement versus time. Maybe if you could construct together, right? Right, so if you know what one time period is and you know the amplitude, then can you make this graph, right? And can you come up with an equation for that? Do that too. Come up with an equation for each one of the, and that's what I said on this card too, 4 graphs and the corresponding equations, right? So can you come up with an equation for each one of those 4 graphs, right? Right. So that, okay, remember, this is like a picture model of what you're doing. Okay. I'm going to leave this table up for a while and walk around the room, help you guys out. Yeah, these graphs. Yeah. Yeah, so there's graphs. Well, I'll split this up different times. All right, so that, let me close out this recording, walk around, help you guys out. And by the end of class today, you'll have a table of data and 4 graphs and corresponding equations.